You've definitely seen a chameleon in a picture, in a cartoon, maybe at a pet store behind glass, and you're sure you know why it changes color. To hide, to blend in with its surroundings. A green leaf, a green chameleon. A brown branch, a brown chameleon. It makes sense, it's beautiful, and it's absolutely wrong. Here's what's interesting. The chameleon might be the only animal on the planet that everyone recognizes at first glance, yet almost everything people think about it is a myth. And the biggest myth is about camouflage. The chameleon doesn't adapt to its background. It doesn't change color for that reason at all. But we'll get to that later, because first we need to understand where this strange creature came from, one that looks like it was created by an artist, not by evolution. Let's start with geography, because without it, the chameleon story doesn't make sense. If you open a map and find Madagascar, this big island to the right of Africa, you'll see an area that's smaller than Ukraine, just a piece of land in the Indian Ocean. But it's here that about 40% of all chameleon species on Earth live. 4 out of 10 species on one island. This isn't a coincidence or a fluke. It's the result of one of the most extensive natural experiments in the history of life. Madagascar broke away from Africa tens of millions of years ago. And from that moment on, everything that lived there was isolated. No gene exchange with the mainland. No new predators coming in to shake things up. Just a closed world where each species slowly, generation after generation, adapted to its specific niche. One chameleon lived in the treetops and grew larger. Another moved lower and got smaller. A third went into dry areas and learned to go without water for weeks. And this went on for millions of years, without interruption, without interference, without competition from outside. The result of this process looks almost unbelievable. In Madagascar, there are chameleons the size of a pinky nail. That's the genus Brookesia. And some of them are so tiny that when scientists first found them, they doubted they were adults and thought they were babies. And on the same island, there are chameleons that grow over half a meter long and weigh as much as a good steak. The size difference is staggering, yet genetically they're related. It's like having mice and bears living on the same island, all descended from a common ancestor. But Madagascar isn't the only habitat. Chameleons live all over Africa, in southern Europe, the Middle East, India, and Sri Lanka. They've adapted to tropical forests, savannas, semi-deserts, and mountain slopes. And here's an important question. If this is such a successful group that has spread across 3 continents and dozens of climate zones, why do most people consider them some kind of exotic oddity? The answer is simple. Chameleons don't want you to see them. Not in the sense of camouflage, but in terms of their lifestyle. They sit on a branch all day. They don't run, jump, or put on a show. If you walk past a tree where a chameleon is sitting, you won't notice it. Not because it blends in with the foliage, but because it simply doesn't move, at all, for hours. And it's not laziness or sluggishness. It's a strategy we'll discuss in detail in the second part. For now, let's return to what chameleons are from an evolutionary standpoint. Many people think they're some sort of primitive lizard, an ancient relic that somehow survived to this day. In reality, it's quite the opposite. Chameleons are one of the most specialized groups of reptiles on the planet. Their bodies are so radically restructured compared to a typical lizard that some biologists consider them a separate branch of evolution that has gone its own way and ventured very far. Their closest relatives are agamas. These are the bearded dragons kept in terrariums, along with spiny-tailed lizards and frilled lizards. The similarities between them now are about as much as between a wolf and a domestic cat. They're both predators, have 4 legs and a tail, but are structured completely differently and live in different worlds. And the most astonishing part is that chameleons and agamas split about 65 million years ago. That's the same era when an asteroid struck Earth and dinosaurs went extinct. while one of the largest catastrophes in the history of life was happening on the planet. Somewhere on a branch of a tropical tree, the ancestor of the chameleon was simply sitting and waiting for its prey, and it survived the apocalypse. This is what this animal really is. Not a cute green lizard from children's books, but the result of 65 million years of continuous specialization. Every element of a chameleon's body, from the tip of its tail to its strange fingers and incredible eyes, is an engineering solution honed by evolution to a state that engineers call elegant. Minimum cost, maximum result, zero unnecessary details. And when you understand this, when you stop seeing the chameleon as just that thing that changes color, everything changes. You start asking the right questions. Not how does it hide, but how does it shoot its tongue faster than a sports car accelerates to 100? Not why is it green, but why do its eyes move independently of each other yet work together? Not why does it have a tail, but how does it hang on a branch for hours without straining its muscles? It's not just a lizard. It's a biological machine that evolution has been building longer than most mountain ranges have existed on this planet. When you look at a chameleon, the first impression is that it's slow. There it is, sitting on a branch, shifting one leg, freezing, then after an eternity, shifting the other. You think, well, there are sluggish animals. Turtles aren't sprinters either. But with the chameleon, it's more complicated. It's not slow because it can't move quickly. It's slow because it's designed that way. Its body is engineered from head to toe for one specific task: to be so inconspicuous on a branch that prey comes close enough to strike. And every detail of this body works precisely for that. Let's start with the tail, because the chameleon's tail is something you'd want to patent. For most lizards, the tail is just a tail. A balancer, a rudder, sometimes a weapon. For the chameleon, the tail is a fifth limb. It coils around a branch in a spiral and holds the body so securely that the chameleon can hang upside down and not fall. But the most interesting part isn't that it holds on, but how it does it. Inside the tail are special tendon structures that work like a latch. When the tail wraps around a branch, the tendons lock into place, and the muscles no longer need to exert effort. The chameleon hangs from its tail passively, effortlessly, without expending energy. It's like if you could hang a backpack on a hook instead of holding it in your hand all day. The muscles only engage when it needs to let go of the branch or reposition itself. The rest of the time, the tail works on its own, purely mechanically. Now let's talk about the legs. If you've ever seen a chameleon gripping a branch, you might have noticed that its legs look strange. Not like the legs of a typical lizard, but more like claws. And this isn't a coincidence. It's one of the most elegant adaptations in the animal kingdom. In most reptiles, the fingers are arranged in a fan, like ours on a hand. The chameleon is different. Its fingers are divided into two groups that come together to form something like pincers or pliers. The branch gets pinched between the two halves of the foot, and the grip is so secure that the chameleon can sleep on a thin branch in strong winds without falling. But there's a detail that makes this system even smarter. The front and back legs are mirror images of each other. On the front legs, 3 fingers face inward and 2 outward. On the back legs, it's the opposite, 2 inward, 3 outward. This creates a cross grip that distributes the load differently in the front and back. The result is perfect balance on any branch, in any position, at any angle. A chameleon can crawl along a branch the thickness of a pencil, and its body will be as stable as if it were on rails. Okay, the tail is a hook, the legs are pincers. But what happens when it's too late to hide and something big comes too close? The chameleon can't run fast. We've already established that speed isn't its strong suit. It can't really bite either. Its jaws are weak. It's not a crocodile. And here's where one of nature's cleverest tricks comes into play, and it's related to its ribs. Chameleons lack what are called presternal ribs. These are the ribs that form a rigid front wall of the rib cage in most lizards. Without them, the rib cage becomes flexible, and the chameleon can inhale air and inflate its body to sizes that look completely unreal. It literally increases in volume by 1.5 to 2 times. At the same time, it turns sideways to the predator, flattens its body in a vertical plane to appear even larger, opens its mouth to reveal its bright mucous membrane, and starts hissing. This entire display is pure bluff. The chameleon can't strike, can't bite seriously, can't run away, but the predator doesn't know that. It sees something inflated, bright, hissing, and in many cases decides not to engage. Psychological warfare without any physical contact. And here's what's worth emphasizing. This works, not in theory, not in a lab, but in the real forest, where the stakes are life. Millions of years of natural selection wouldn't have preserved this mechanism if it didn't yield results. Bluffing as a survival strategy isn't a weakness, it's an economy. Why spend resources on armor, venom, or muscle mass when you can simply scare someone off? Now let's look at a specific example of how a chameleon turns one part of its body into a multifunctional tool. The Yemen chameleon is one of the largest and most recognizable species. It has a high bony crest on its head, a triangular helmet that makes it look like a little dinosaur. It seems like a decoration, a species characteristic, maybe just for looks. In reality, this crest serves at least 3 functions simultaneously. The first function is water collection. The Yemen chameleon lives in dry areas where rain is rare, but morning fog or dew is regular. Water droplets settle on the surface of the crest and trickle down to the corners of its mouth. The chameleon drinks dew from its own head. It's a built-in water collection system that requires nothing from the animal. No effort, no movement, no searching for a water source. The second function is thermoregulation. The crest increases the surface area of the head, allowing the body to warm up faster in the morning sun and release excess heat more quickly in the shade. For a cold-blooded animal that depends entirely on external temperatures, this is a critically important function. The third function is communication. The size and shape of the crest tell other chameleons about the age, health, and status of its owner. A male with a large, symmetrical crest sends a signal: "I'm healthy, I'm strong, you'd better not mess with me," and rivals read this signal long before any conflict arises. One structure, 3 functions, no unnecessary details, no duplication. This is what engineers call an elegant solution, but here the engineer is natural selection, and the development time spans millions of generations. And when you put all this together, the latch tail, the pincer legs, the inflatable body, the multifunctional crest, you start to see the chameleon not as a cute reptile from a pet store, but as a creature with no random elements. Every inch of its body answers a specific question: how to survive on a thin branch without wasting energy, attracting attention, or entering into direct conflict with anyone. But the body is just the platform. The craziest part about the chameleon is what's in its head. Its eyes and tongue are 2 tools that, in their characteristics, go beyond what we're used to seeing in reptiles. Everything we've covered so far, the tail, legs, ribs, crest, is infrastructure, the platform on which the chameleon sits and waits. But sitting and waiting is pointless if you can't accurately determine where the prey is, how far away it is, and when exactly to attack. And this is where the part of the chameleon story that truly blows your mind begins. Because its sensory system isn't just good vision. It's a whole complex of solutions, each unique among all vertebrates on the planet. Let's start with the eyes, because the chameleon's eyes are the first thing anyone notices when they see it in person. 2 bulging cones, each of which rotates independently of the other. One eye can look forward while the other looks back at the same time. One tracks a fly on a neighboring branch, while the other checks if someone is sneaking up from behind. It looks comical, but in reality, it's one of the most sophisticated observation systems in the animal kingdom, and it operates on a principle that's found nowhere else. The chameleon's two hemispheres of the brain process visual information independently of each other. Literally, one eye sends an image to one hemisphere, the other to the other, and these two hemispheres work in parallel, like two separate operators sitting at two monitors. At that moment, the chameleon sees two different images simultaneously and processes both. This isn't distraction, it's panoramic mode, almost a complete circular view without turning its head at all. But here's what happens when one of the eyes spots something interesting. Let's say there's a grasshopper sitting 20 centimeters away on a branch. At that moment, the chameleon's brain switches. Both hemispheres synchronize, both eyes focus on one point, and the chameleon shifts from panoramic mode to binocular. Now it sees not two separate images, but one three-dimensional image with an accurate assessment of distance. And this ability to switch between two fundamentally different modes of vision in a fraction of a second has no analog in any other vertebrate. But even more interesting is how the eye itself is structured internally. In most animals, the lens is a lens that focuses the image on the retina, much like a camera lens. In chameleons, the lens and cornea work together like a telescope. They don't just focus light, they magnify the image right inside the eye. This means that a chameleon sees small objects at a distance significantly larger than a lizard of the same size would. A fly at tongue's length looks to a chameleon as if it's sitting right on its nose. It's a built-in binocular, sewn right into the anatomy of the eye, and other vertebrates don't have this. And now for the freshest discovery that has overturned scientists' understanding of how chameleons communicate with each other. In 2018, researchers found that the bony crests and protrusions on chameleons' heads fluoresce under ultraviolet light. This means that under ultraviolet light, these structures start to glow. The human eye can't see this. To us, it's just bone under skin. But chameleons can see the ultraviolet spectrum, and for them, these glowing patterns on each other's heads are like neon signs. Each species has its unique glowing pattern. This means that chameleons in dense tropical forests, where everything is green and similar, can distinguish their kin from outsiders by the glowing spots on their skulls. A hidden communication channel that has been working for millions of years, and humans only discovered it a few years ago. All right, the eyes have found the target. The distance is determined. Now it's time to catch that target. And here we come to the chameleon's tongue, which deserves a separate film all on its own. The chameleon's tongue can reach a length equal to 1.5 times its own body length. It shoots out of its mouth and reaches the target in a time you can't even comprehend. It's fractions of a second. The acceleration during the shot exceeds the acceleration of free fall several times over. If a car accelerated with that intensity, it would reach 100 kilometers per hour almost instantly. But here's what's truly astonishing. This speed is not provided by muscles. Here, the principle that physicists call elastic energy storage comes into play. Inside the chameleon's tongue are collagen structures, dense, elastic tissues that the muscles preload like you charge a spring by pulling back a slingshot. The muscles slowly compress these collagen elements, storing potential energy in them. And when the moment to attack comes, the energy is released all at once, and the tongue flies out not due to muscle contraction, but due to the recoil of the spring. The muscles only charge the system, while the shot happens passively. And here's why this is genius. Muscles work slower when it's cold. Any lizard in the morning, before it warms up in the sun, moves sluggishly and hunts poorly. But a chameleon can shoot its tongue even at low body temperatures because the speed of the shot depends not on the muscles, but on the elasticity of the collagen. And collagen doesn't lose its properties in the cold. This means that a chameleon can hunt early in the morning when other cold-blooded predators are still barely moving, occupying a niche that's simply unavailable to competitors. But shooting is only half the battle. It also needs to hold on to its prey. The tip of the chameleon's tongue isn't just a sticky pad, as many think. It's a vacuum suction cup. Upon contact with the prey, the tip of the tongue deforms, wrapping around the surface of the insect's body, creating a low-pressure zone, a vacuum pocket. The holding force of this pocket exceeds the weight of the prey several times over. It's like if you lifted a weight with an industrial suction cup. Even if the weight is wet and slippery, it won't go anywhere. The chameleon doesn't miss, and if its tongue touches the prey, it's already caught. Put all this together. Telescope eyes with panoramic and binocular modes, secret ultraviolet communication, a catapult tongue with vacuum grip that works at any temperature. These aren't separate tricks. They're a unified system of precise targeting, where each element complements the others. The chameleon doesn't chase its food. It sits, scans the space in 360 degrees, finds a target, aims, shoots, and hits. One movement, one result. Energy expenditure is minimal, efficiency is maximum. And now that we've covered the body and the weapon, we need to understand how the chameleon lives, how it communicates, how it reproduces, how long it lives, and why the answers to these questions sometimes shock even biologists. The chameleon is a loner. It doesn't live in groups, doesn't build nests, doesn't raise offspring. It spends most of its life alone on its branch, and if another chameleon appears on the horizon, it's almost always a problem, not a joy. You'd think that with such a lifestyle, communication wouldn't be necessary. Why talk if you're sitting alone your whole life? But here's the paradox. Chameleons have one of the most complex and developed communication systems among all reptiles. It just doesn't work through sound, but through light and geometry. When two male chameleons notice each other, what happens next is what biologists call a visual duel, and it's a sight worth seeing at least once. Both males start changing color, not to hide, but quite the opposite, to become as bright and noticeable as possible. They puff up, turn sideways to appear larger, rise higher on their legs, sway on the branch. This entire display isn't a dance or a ritual for beauty, it's negotiation. Each male shows the other its size, brightness, and readiness for conflict, and in the overwhelming majority of cases, that's enough. One of the two assesses the rival, realizes it will lose, pales, shrinks, and retreats. The conflict is resolved without a single bite, without a single scratch, without the risk of injury, which in the wild almost always means death. From an evolutionary standpoint, this is a brilliant strategy. Physical combat always comes with a cost. Even a winner can get a wound that becomes infected, slows it down, and makes it vulnerable to predators. The visual duel completely eliminates this problem. The one who looks stronger wins, not the one who is actually stronger. And this works because in nature, size and brightness are fairly honest indicators of health. A sick or weakened chameleon physically can't display the same bright coloration as a healthy one. The system regulates itself, but while the body structure and hunting methods of different chameleon species are generally similar, there's one parameter with such a huge range that it's hard to believe. That parameter is lifespan. In Madagascar lives a chameleon named Laborde. Small, unremarkable, just over the length of a finger. Its life cycle is one of the shortest among all terrestrial vertebrates on the planet. An adult Laborde chameleon lives about 4 to 5 months, not years, months. The entire population synchronizes. Eggs are laid in one season, hatch in another. Young chameleons grow rapidly, mate, lay eggs, and die. All of them. By the beginning of the dry season, there isn't a single living adult Laborde chameleon on the island. Just eggs in the ground, waiting for the next rainy season. If you consider the total time of existence, from the moment an egg is laid to the moment an adult dies, it's about a year. And most of that year, the chameleon spends inside the egg. It exists as an adult animal for less time than as an embryo. It's almost incomprehensible. Now take the other extreme, the Parsons chameleon. It's one of the largest chameleons in the world, heavy, calm, with a massive head and slow movements. The Parsons chameleon can live up to 20 years. It has a slowed metabolism, reproduces rarely, and grows slowly. Two representatives of the same family living on the same island, and there's a difference in lifespan of almost 40 times. It's like if among humans, some lived for 2 years, while others lived for 80, and both options were considered normal. Such a range isn't a whim of nature, but a response to different environmental conditions. The labored chameleon lives in a region with sharp seasonal changes, where the dry period is so harsh that an adult can't survive it. It's easier to invest all resources into eggs and restart the cycle from scratch. The Parsons chameleon lives in humid forests where conditions are stable year-round, and a long life becomes a beneficial strategy. The longer you live, the more offspring you leave behind. Now let's talk about the chameleon's place in the ecosystem, because this is an important piece that usually gets left out of popular narratives. The chameleon isn't just a cute reptile sitting on a branch and bothering no one. It's an active participant in the food chain, and in both directions. One chameleon can eat dozens of insects in a day. Multiply that by hundreds of thousands of chameleons in one forest, and you get a significant force regulating insect populations in the ecosystem. Without chameleons, the numbers of certain beetles, flies, and grasshoppers would rise, leading to a chain of consequences affecting plants, soil, and other animals. At the same time, chameleons are an important part of the diet for predators. Snakes, especially tree species like boomslangs, hunt them regularly. Birds of prey pluck them from branches. Even some large spiders can handle smaller species. The chameleon is a link in the chain that connects insects with larger predators, and if that link is removed, the chain starts to break down. And this is where we come to what makes the future of chameleons truly concerning. One could say general things: deforestation, climate change, pollution. All of this is true, but chameleons have their own unique vulnerability that sets them apart from most other animals. Chameleons don't come down to the ground. More precisely, they do so extremely reluctantly and only in exceptional cases, like when a female needs to lay eggs. Their entire lives are spent in the treetops and shrubs. And this means that even a narrow strip of deforested land, a clearing, a road, a cleared plot, becomes an insurmountable wall for them. A chameleon won't cross an open space 30 meters wide. It simply won't go across bare ground because its entire body and instincts are designed for life on a branch. On the ground, it's slow, defenseless, and visible. This is called habitat fragmentation, and for chameleons, it's worse than for deer, wolves, or even most birds. Those can go around, fly over, or run across. Chameleons can't. Every cleared corridor divides the population into isolated groups that can no longer exchange genes. Small populations degenerate, lose genetic diversity, and go extinct one after another. The forest can stand, the trees can grow, but if there's no connection between patches of forest, for the chameleon, it's no longer one forest, but 10 tiny islands, each with a ticking clock. This is what this story is really about. Not about a funny animal that changes color, but about a creature that has spent 65 million years perfecting every element of its body, building one of the most elegant survival strategies in nature, and now finds itself a prisoner of that very strategy. Because the world around it is changing faster than evolution can respond, and a clearing through the forest, made by a bulldozer in a single day, destroys what nature has been building longer than the human species has existed. Thanks for watching, and if you enjoyed the video, please like and subscribe to the channel.